class. Can everyone give me a green check if they can hear me adequately? All right, great. Thanks. Well, welcome to session 1 of IE701. So over the next 8 weeks, we're going to be taking, kind of a high-level look at probably one of the most important components of an IT infrastructure, and that's basically your network infrastructure. Basically, all the components, all the protocols that kind of serve as the foundation for all of the services and applications that you host in your infrastructure. So whenever we speak about network engineering, or your network infrastructure, basically we're talking about your road infrastructure for all of the services that you provide to your customers. So, for any application, any service, any web service, regardless, you have to have a robust and stable network infrastructure in place. And, as we move forward in time, we're not just talking about basic web browsing, basic email, basic text, basic small amounts of data that's being transported across these network infrastructures. We're talking about huge amounts of data, and when I say, the textual data such as documents, email, what have you is not much. On a one-on-one basis, of course, a document is not much, but we've been running IT infrastructures in businesses for decades now. So we've got, really a critical mass of data that exists in these infrastructures. So I'm not belittling some of the traditional services that, that we provide or that we host. But, moving forward, we're going to be talking about a lot more data, a lot more network intensive data that's going to be transported across these infrastructures. We're talking about things such as virtual desktop infrastructures, where basically you have a thin client or a zero client, which sits at the user endpoint and connects back to a centralized desktop infrastructure. So we're talking about things like VDI, which have relatively intensive network throughput requirements. We're talking about things like voice over IP. Again, where you're taking something that was traditionally on a separate, copper infrastructure and moving that also onto your consolidated Ethernet network. Talking about things like IPTV, which a lot of organizations may or may not host these days. We're talking about video teleconferencing. All of these are things which require you to have a robust foundation to support offering these types of, services to your user community. And of course, there's a lot of other stuff wrapped around that as well, right? There's, security is a huge concern, especially after, last week when we found out that, I guess 4 million federal employees' information has been compromised. So there's that. There's business continuity of operations. So, beyond just making sure that you provide a network infrastructure with high quality of service, high throughput, and high bandwidth availability, you also have to think about the other things for managing the sustainability and the operations of that network infrastructure. So over the next 8 weeks, we'll be kind of starting out at a foundational level and starting with some basic some basic concepts and building out from there. So as far as the course objectives of IE701, well, the course description. So the integration of internet-based communication with information technology systems has transformed the way people conduct business. Access to the internet enables companies to reach markets worldwide, governments to interact with every facet of society, and people to obtain professional education and manage their personal lives. As our society becomes more information dependent, so does the need for network engineers and planners to increase information capacity and capability while reducing costs. The trend for accomplishing these needs involves the migration of traditional networks to a single transfer control protocol, internet protocol-based platform capable of seamless integration with public and private internet. And, to be honest with you, we were just kind of briefly talking about this. We are seeing a collapse of what was historically separate wireline infrastructures onto a single IP network, even within the organization, right? I mean, previously, if you wanted to offer cable TV services to your customer base, you had to have coaxial cable run throughout the offices. For older legacy phone systems, you actually had to PBX. You had to have a PBX on site with a PRI connecting you to your external telephony provider, and you had to have twisted pair, probably RJ11, run to all of your offices to support that, and that was separate. And so those two things were in addition to whatever Ethernet runs that you had, as well as the backend network infrastructure that supported that. But again, as the syllabus says, at this stage in the game, we're kind of collapsing and consolidating all of those different services. Again, voice telephony, we're going over voice over IP, video, we're going over IPTV or whatever other streaming technologies are out there. Video teleconferencing being another big one. For example, traditionally, folks had to get on a airplane and go to a consolidated location if they wanted to have a face-to-face discussion or meeting. However, these days, with large screen TVs and VTC type equipment, you can easily facilitate a low-cost face-to-face conversation between folks in different time zones, if not different continents, over this network IP infrastructure. So it's kind of an important concept to think that what has traditionally been different domains of services are all collapsing onto a single infrastructure, and that's in addition to, again, the services that have traditionally went over Ethernet, your web browsing, your email, your application services, your accounting applications, what have you. All of that stuff, again, is going to be run over a single IP infrastructure. So again, the course teaches the architectures, topologies, hardware components, and software applications that comprise the internet and companion IT systems. So, again, we're going to be looking at kind of taking, a foundational perspective and building up from there. Take a look at the basic networking concepts, basic applications and software components that support communication on a network infrastructure, and, the various components that allow you to provision out services to your user community. So that's basically, the course description. The course objectives, we have several of them, and these are on page, 1 of your syllabus. The syllabus is online up in the files section. If you haven't downloaded it, go ahead and download it and take a look at it. But from the perspective of course objectives, we have like 8 of them. So we want to understand the various network structures and what purposes they serve. So, network infrastructures, basically, as far as wireline infrastructures are concerned, basically you have inter-building, if you will, network infrastructures, which are basically your local area networks, even if it potentially crosses multiple buildings. But then you also have your, inter-building or external to the organization, your wide area network infrastructure. So we want to take a look at the various type of network structures that you may or may not implement for an organization. Of course, the internet, critically important. It's become part of the enterprise's network infrastructure. You can use things such as VPN gateways to facilitate communications between the same organization across different geographical areas. Often you use the internet to facilitate employees that are either at home or traveling to be able to reach back into the corporate network or government network or what have you, to be able to continue to work even when they're not at the physical work location. And of course, with things like telecommuting and things like that, those type of capabilities become even more important. I want to take a look at the principles and properties of protocols used in networks. So we'll take a pretty good look at things such as TCP/IP. Take a look at its history, the different layers, the different protocols that compose the TCP/IP protocol stack. We'll take a look at congestion control and resource allocation principles and techniques. So again, that's going to be one of your jobs as a network engineer. You have to manage load and capacity across your infrastructure, and there's different tools that you can use to facilitate that. So for example, if you have customers that are over consuming your network infrastructure, you may want to look at things like quality of service, traffic shaping, things like that can help you prioritize your traffic and make sure that the folks and the applications that need the guaranteed available bandwidth have access to that bandwidth, and that maybe less prioritized traffic may have to wait for the higher priority flows or what have you. So we'll take a look at some congestion control and resource allocation techniques. Of course, we want to appreciate the need for network security and introduce the networks during the design phase, the latest techniques to make networks more secure. And of course, this is, as we move forward in time, securing your network infrastructure along with all of the services and applications that ride on top of it it's hugely important, right? I mean, you have to patch your servers, leverage robust passwords or what have you, but you have to go through the process of securing your network infrastructure to ensure that malicious actors are not able to take advantage of your certain vectors to gain access to your internal information. We want to take a look at the particular network requirements of internet-based applications, including things like domain name services, which is basically how systems map human-friendly names to IP addresses across the infrastructure. We'll take a look at electronic mail, how that functions across the infrastructure. We'll take a look at the World Wide Web, some multimedia infrastructures, some overlay networks, as well as some network management techniques, things such as SNMP, to be able to manage the health and availability of your network services. We'll take a look at OpNet, which is basically the family of network designing and modeling tools. Now, a note of interest here. OpNet was purchased, I think end of last year, by a company known as Riverbed, and they have released a new version. So I've been through some of these labs, and I've identified areas where the changes to the latest revision of the IT Guru software does not function quite properly with the lab as is defined in the lab manual. So we're still going to work through all of the labs. However, we just have to be aware that we may run into areas where there's some differences in what's asked of you from the lab manual and what's actually available there in the software. So again, I'm going to ask you to work through these laboratories. I grade your completion of the labs despite whatever problems that you run into during the execution of the laboratories. So I just expect you to work through the labs to the best of your ability, note where you have any problems, and the deliverable will just be a final run of the simulation. but we're just, this class, we're just getting familiar with, some types of modeling software. So I don't expect perfection. And of course, we have the added complexity of the software being upgraded by the new owners. And, Riverbed, I think, is a pretty well-known name. I know they do, I believe they do encryption across network links, things like that, so you can do, secure your network links to various locations. But I know they're definitely a player in the network infrastructure environment. So we got to be aware of that. And, we'll go over it more over time. But the expectation is that you work through the lab. I'm not expecting you guys to do the exercises at the end of each lab. Basically, I just want you to work through it, run the simulation, take a snapshot of the final run of the simulation, put that in a Word document, and then that's what you submit to me for the class participation portion of your grade, for the homework portion of your grade. And again, we're going to run into problems. There's definitely identified areas where the software is not quite in step with the lab manual. So, we'll just keep that in mind as we work through these things. And of course, communicate technical concepts effectively in writing. So, there's a paper due at the end of class. But that's basically the course objectives for the class. Now, as far as your grades are concerned, so basically there are 4 components to your grade. There's class participation. Now, class participation is basically showing up every week for class, as well as completing the laboratory exercises and getting them back to me at the end of class. So, basically I'm going to ask you to do all of the labs. I don't expect them to week 8. So, you probably want to try to do 1 or 2 a week to keep going, and, kind of to ensure that you're able to complete all of the labs. But, so the class participation portion, again, it's a combination of showing up, or, if you can't show up, please just hit me beforehand in an email. Let me know that you're unable to make it. I understand that, we're probably all working adults here. We probably all have families and children. So I completely get that some unforeseen issue can pop up and cause you to miss class. I just expect you to notify me beforehand, and then afterwards, just take the opportunity to listen to the recorded lecture and just ensure that you get all of the deliverables done during the course of the class. Class participation, it's worth 200 points. The next up, we have the midterm exam, and that's, that'll go out, I guess, around week 3, week 4. That is a proctored exam. The midterm will cover the first 4 weeks of class, first 3 or 4 weeks of class. I'll give you guys more information as we get closer. But it is proctored. So what that means to you is you need to identify a proctor who can oversee your execution or your writing of the exam. So basically that means you would identify a professional acquaintance, be that a coworker, a boss, a teacher, or somebody of that nature. Rick Sample, the director of library services at Capitol, he can oversee your proctoring, or he can be your proctor for the exam. But you need to identify somebody who you can meet with who will oversee your completion of the midterm exam. You need to send me the email address for that person, and I'll go ahead and compile a list of all of the proctors for all the students. On the week that I release the midterm, I will send the midterm to your proctor. You will then schedule a time to take the exam under the proctor's supervision. You will take the exam. The proctor will then sign the document and email it back to me, or sign and scan the document and then send it back to me. I'll then grade it and get you your grade back to you as quickly as possible. But that's basically what that process looks like. Now, we still have a few weeks, so you have 2 or 3 weeks for you to identify a proctor, but you'll need to go ahead and do this because the time in this class goes by quicker than you would think, and with all of the other work that you'll have to do, time will go by pretty quickly. The midterm exam, 200 basis points. So that's another component as well. That's the second component of your grade. Third is a graded lab report exercise, and that will go out as well. Basically probably what I'll do is I'll just ask you to go ahead and fully complete one of the labs that you're already working on and get that information back to me, and just follow the layout in the lab manual and return that to me. So it shouldn't be too difficult for you. But that'll be worth another 200 points. And then finally, at the end of class, you'll have a final exam. And that'll be around week 7, I believe, week 6, week 7. And that'll be worth 400 points. So basically, it's, coming up with your final grade is pretty simple. You want to take all of the points that you receive, and you should know about where your class participation grade is, and you can just sum them up. And then, the grade table is on page 2 of the syllabus. 900 or above, you get an A. 800 to 899, you get a B. 700 to 799, you get a C. 600 to 699, you get a D. Anything below 600 is an F. However, as a graduate course here at Capital, you want to try to ensure that you make an 800 or above, because B is basically the baseline. So that's basically your graded events, as well as how you are graded for the entire class. As I said before, class participation, 20% of your grade. Midterm exam, 20% of your grade. Graded lab report, 20% of your grade. Final exam, 40% of your grade. And that's basically it. I mean, it's pretty simple, folks. Meeting times and dates. So we will meet every Monday for the next 8 weeks. We'll start at 7, and I'll keep us going probably till about 9:30. Some nights longer, sometimes shorter. And any other additional time that we have at the end of class, I want you guys to go and work on your labs, because that is a bit of work, working through all of those things. But again, if for whatever reason you can't make it, please again just let me know beforehand. As far as the virtual concept or the virtual classroom concept, I'm sure both. You've probably all been through these online classes before. I'm sure that this is not your first one, but basically there's kind of a online component or a synchronous component, and that's basically this. The lecture is the online component, and then of course the asynchronous is just doing your work, doing the readings in the book, etc. So, basically, that's it. As far as the schedule is concerned, so let me see here. All right, so this is week 1, the live session. Nothing's really due tonight. Just ask you to start working on your OpNet laboratories. Week 2, nothing's due there either. Continue your readings, continue your OpNet laboratories. Okay, then week 3, again, we continue on with your OpNet laboratories. The graded lab report, that'll go out in week 3. So live session 3, I think that's a few weeks from now. I'll distribute the graded lab exercise. That'll be due back in week 4. Hey, stop. Week 4, the graded lab report is due. And also the midterm will go out, your proctored midterm. So again, you'll want to get me your proctor no later than week 3, if possible. I mean, of course, I'll take them between week 4 and week 3. But, the sooner that you get them, the easier it is on me. The midterm exam is due back in week 6. The final exam goes out in week 6 as well. And the final exam is due back in week 8. And then also all of your labs are due back in week 8 as well. So basically, that is what the schedule looks like. And basically, that's the layout of the class. For 5 or 10 minutes before we get started with each week's lecture material, I'll take 5 or 10 minutes to go over administration. Where we're at in the class, what's coming up, what you need to do. But one thing is the OpNet labs. Go ahead and work through them. I mean, they can be kind of challenging. Even without the complexities of the software upgrade that Riverbed has brought to the table. So again, the expectation is that you're able to work through them, document any problems, and just give me a screenshot of the actual execution of the simulation. And that's all. And I just want a screenshot of that final execution of the simulation. You put that in a Word document. You put all of them in a Word document, you send it to me, and that's your deliverable. Again, for the vast majority of the labs, I do not expect you to do the exercises at the end of the lab, and I don't expect you to do anything special beyond a screenshot of the execution of the simulation. And that's pretty much it, as well as help me document any inconsistencies in the software that we run into with the version update. And that's and that's basically the course in a nutshell. Do you guys have any questions about the expectations or the administration or anything of that nature? All right then. So I just want to get kind of a brief introduction from you guys. I want to go through each person and just give me a brief introduction. Tell me about your academic background, your work background, as well as your expectations for the course. Tell me about if you have any networking expertise in the past. Are you in the Internet Engineering program, or I suspect a number of you are coming over from security or what have you. So again, just give me a very brief academic background, career background, and kind of your expectations for the course. And I'm just going to start at the top of my participants list and work my way down. So let me see, microphone rights for all participants. And I'm going to start with Danny DeFresnay. Danny, could you just give us a very brief introduction?
Yes, can you guys hear me? Hello? Hello? Can you guys hear me?
Yeah.
Yes, we can hear you, Dan.
Okay. My name is Danny DeFresnay. This is my second semester. I'm taking 2 classes in the summer. studying in internet engineering. My profession, I'm an RF engineer for a major telecommunication company. And yeah, I just hope that I can just learn to add some skill sets, really widen my scope, so that I could put into practice a little bit more and a little bit more. Also, professionally define myself. So thank you. Thank you.
All right, thanks, Danny. The next person would be
Yeah, hi, my name is Danny. I currently work as a technical consultant for a small company. I have some network administration background, and I just want to fill the gaps, kind of in my skill set with this class, and I hope to learn a lot, especially in terms of the monitoring and the congestion and relieving those problems within a network.
Thanks, Danny. Next up would be David Weiser. David, could you just give us a brief introduction, please? Academic background, career background, and expectations for the course.
Yes, good evening. My name is David Weiser. I have a bachelor's in electrical engineering. I also am going for my master's in electrical engineering right now. I basically have been employed as an engineer for 28 years doing reliability engineering. Hello?
Okay, great. Thanks, David. I'm sure you'll get some value out of the course. Next person we would have would be Dominga Bellardo. All right, so audio not working, but working telecom. Want to learn more about cloud engineering. Now, cloud engineering, we'll touch briefly on it because it's kind of an interesting concept. I'm sure most of you are pretty familiar with cloud engineering, but I mean, basically, the idea is historically, traditionally, for services and applications, they've been run internally within an organization by an IT staff and made available to all of the customers. But, what we've been seeing over, I guess, the last, at least 5 years, maybe 5 to 10 years, is we've been seeing kind of an outsourcing of what has traditionally been internally managed services and applications. And basically, these two trends are known as IaaS as well as PaaS. IaaS is infrastructure as a service. And then, of course, there's PaaS, which is platform as a service. And basically, the idea here is that you take what has traditionally been internally run applications, maybe these include authentication applications, maybe these include database applications, email applications, what have you, and you outsource those out to a external vendor. Can you hold on just a second? Sorry about that. So basically, they are outsourcing these applications out to an external vendor. And the internal IT organization will no longer run those applications and services directly. Now, of course, there'll be some type of front-end interface or what have you, like a virtual data center or a virtual application management piece or or something of that nature. But basically, the care and feeding of that service is moved external to the organization. Um, Now, from a network perspective, that can be quite important. Because likely you're going to have dedicated fiber runs, probably from your different physical locations to the cloud vendor, because you don't necessarily want to run or access those services and applications over the internet. You probably want to have dedicated, back office links to the service provider. So there's, that consideration. And, there's also the, security considerations, as well. So cloud computing, I'll try to touch on it throughout the class, because there are certainly, considerations. In that you're moving your infrastructure external to the physical location of your organization. And, there's a lot of questions wrapped around that. Now, normally your vendor will, have responses. For example, if you have like a large amount of critical data that you're moving into a cloud vendor, how do you guarantee that the data is not compromised by the cloud vendor? Oh, they have processes put in place where, maybe the data is encrypted both at rest as well as when it's in transit. So they'll have, protections and other things that they'll talk about. But it's, again, it's a pretty important trend these days. And it's a trend that's likely not going away. And of course, as Dominguez says, there's Amazon Web Services, there's Google services, there's Microsoft Cloud services, there's tons of small vendors which provide cloud services to the federal government around here. There's FedRAMP, etc. So bottom line, from a network cost effectiveness, is there a true cost savings? No, I don't think so, because you still have to run those applications across your network infrastructure. You will always have users local to your environment. So the cost savings come from the actual management of the infrastructure, the system infrastructure that you're moving out. For example, email, you should gain some cost savings because you're not having to have a capital investment of buying tons of servers, buying tons of expensive storage area network storage, huge numbers of SSD drives or fiber channel drives. You have to worry about buying Brocade fiber channel switches. You don't have to worry about paying for FTEs, which handle the care and feeding of those systems. You don't have to worry about the security, theoretically, because the vendor should be handling the patching and any security advisories that are related to that service or application. So that's theoretically where you should be getting your savings from. But from a network perspective, you still have to project the service or the application, whether it's physically on premise or off premise, to your end user desktop. Like it or not. Unless you also talk about moving your desktop out into the cloud as well. And there are certainly instances where people are moving their desktop, a virtual desktop infrastructure environment out into the cloud as well. But of course, you still have to deal with the network requirements, which are significant, of projecting those desktops down to a zero client at the user desktop, because they still have to access it, whether it's cloud-based or whether it's, physically on premise. So I mean, there's definitely cost savings to be had. Whether it's on the network side, I don't think so, but I think it is on All right, great. Thanks, Ethan. We'll definitely, hopefully expand on your foundational knowledge throughout the course of this class. Security is a big topic. We'll see if we can fill in some of those gaps for you. The next person that I have on my list.
Hello, can you hear me? I hope. Uh, okay, I have a bachelor's degree in information systems, and I've been in IT for a pretty good long time. I'm retired military, worked in contracting for a while in IT, and right now I work for a very large IT DoD organization. And I'm just looking to pick up some new information and stay current. Cloud computing is a big thing that my organization is involved with right now, trying to expand out into the cloud. So also mobile networking, just anything that's a little new to me, is what I'm looking for, just to keep up with the industry. That's about it.
All right, great. Thanks, Fritz. Well, you'll definitely get some of that information from the class. The next person on my list is Gabriel Muir. Gabriel, could you give us a introduction, please? Yes, we can hear you, Gabriel. The green checks mean that we can hear you. Great. Thanks, Gabriel. Next person on my list is Jamie Cox. Jamie, could you give an introduction, please? Jamie, you may be having some audio issues. You can just type it in the chat when you get a chance. After that, we have Luke Harris. Luke, could you give us a brief introduction of academic background, career background, and kind of your expectations for the course, please?
Yeah, I have a background. My bachelor's is in computer information systems. Background is in voice over IP and video over the DoD ubiquitous network. I work, I'm retired Air Force. We manage the voice over IP integration across the IP for DISA on the DoD and manage the backbone for that and engineer the router switches and hubs for making sure that voice and video across it is managed under quality of service and things like that. So I'm just looking to get more solidified on foundations that I have for networks. Thanks.
All right, great. As I spoke about before, voice over IP is it's a pretty important thing these days. I'll see if I can fit some material on voice over IP into one of the sessions as well. First on my list is Marcus Howard. Marcus, a brief introduction, please.
Yes. My name is Marcus Howard, and I have a bachelor's degree in computer science. I've been working in the network security / cybersecurity field for about 7 or 8 years now. I have a few cybersecurity related certifications, a couple in management, and a couple hands-on. And I'm just here to basically fill some gaps because my job. I work for a utility company in the Maryland, in the state of Maryland, and we're doing a lot of convergence right now. So I just want to get a better handle on what processes they're dealing with and what we need to secure.
All right, great. Thanks, Marcus. Next on my list is Max Shantar. Max, could you give us a brief introduction, please?
Yeah, good afternoon, everyone. My name is Max Shantar. My bachelor's in information technology. I'm currently at Capital, about halfway through the cybersecurity information assurance program, and that's been my career for about the last 10 years. And before that, I was a general sysadmin and network admin, so I did have some exposure, and certainly in cyber, we're always dealing with the network defenses. So I have some baseline certs like the CCNA, Network Plus, and some of those more entry-level networking certs. But what I'm really looking to get out of this class is taking, particularly the labs, looking through the lab manual. That looks really interesting to me, rather than just relying on vendors telling us what hardware we think will work for a network, actually taking a quantified approach and looking at actual data to simulate use cases. So I think that's what I'm looking forward to most in this class.
All right, great. Thanks, Max. Next person on my list is Pamela Cross. Pamela, could you go? All right, Pamela, it sounds like you're busy there. If you could just maybe type it in the chat area, and we'll take a look at it. Next person on my list is Robert Douglas. Robert, could you give us a brief introduction?
Good evening, class, professor. My name's Robert Douglas. My background is in telecommunications. I have a bachelor's degree from Capital, a longtime student. Been in the industry for almost 20 years now. Been a network engineer. Currently, I am a DMTS in the FiOS integration lab, working with the access and transport equipment, routers, and the FiOS vendor gear, doing integration and end-to-end testing. We do a lot of VoIP, IPTV, and stuff like that. So looking forward to just getting any more knowledge I can about the multitude of multimedia services provided over IP. Thank you.
You might be having some issues as well. So I think this is a good place to take a break, class. Do you guys have any questions about the administration or the requirements or the tasks or anything of that nature? All right, then let's go and take about a 15-minute break. I'm showing it's about 7:50, 7:51. So come back about 8:05, 8:06.